Thanks for coming. I'm going to talk today about, I'm going to stand on a soapbox a little bit and talk about what I've been seeing in the industry through my experiences at Google and now at WeBeData here over the last 8 years or so in combination of the two, about what people are doing with big data technologies. I've seen largely that people are working on ETL. They're doing fancier ETL, they're ingesting more data sources, getting it to the point where they can begin to understand and ask questions and do a little bit of BI. I've seen early adopters do that because they've needed to prove value right away to the business to justify the expenses for migrating their existing systems and IT stuff to Hadoop. But then I've seen very little activity in terms of moving on from there. I've seen some early adopters do it. A lot of the companies that you represent today at a conference like this, that's very early adopter heavy. But I'm seeing a lot of larger organizations that are still stuck on the ETL thing. And I really want to encourage people to move on and shed some light on why there's a lot of value there, why it's maybe a little bit easier than you think it is, and get people moving along. So what I'll talk about today, I have three kind of courses for you. The first little introduction, I'll tell you a little bit about myself. And I want to tell you a little story that helps shed light on why I think the industry is moving the way it is. I have some unique perspective, having the luxury of working in a place like Google, seeing the technology grow, and then seeing that same thing play out in industry and in open source. With that intro, I think we're going to highlight a few blind spots that I think, as a company that is not necessarily an early adopter, but maybe an early majority, might not see so well. I think it's difficult to see the very next generation use cases that some of the early adopters are working on. It's difficult to see the architecture patterns that people are using. There's so many different technologies out there, and people are gluing them together in different ways. I want to show you some examples of what people are doing well and maybe not so well. And then way further out, the art of the possible. Where do I think the real value is that is actually maybe closer than you think, and I think is in reach if you do things correctly. And then last, I'll leave you with a pretty strong opinion of mine, an ask that people actually start moving on from this ETL stuff to the more interesting use cases. And I'll leave a lot of time for questions. So just this is not a good venue for questions in the middle, but if you do have something, I'm happy to field it. And just raise your hand and I'll call on you. So who am I? So I grew up at Google. I worked there for 5.5 years, here a little bit in Mountain View, a little bit in New York. I started out in the search quality team, core search technologies, trying to figure out a focus on personalization. How can we collect all the information across Google properties about what people are searching for, clicking on? As we grew new properties, what are people watching on YouTube or reading on Google News? And can we collect all that information and put it in one place so that we can actually start doing something useful with it? Certainly at Google, we were already collecting this. This was sitting in log files across distributed machines. But the first step, luckily, we were privy to a lot of the internal Google technologies. We had GFS, MapReduce, Bigtable, the things that are inspiring a lot of the Hadoop development even today. So we were lucky to have that as early adopters internally to really get everything in one place so that we could start to infer the taste and preferences of users. When you search for Jaguar, do you mean the car or the animal or the operating system? So I spent a lot of time on that personalized search piece and then moved on to personalized recommendations. We got so good at a point that we knew that if you were logged in and came to google.com, we knew so much about you that if you didn't type anything in the search box, you just clicked "I'm feeling lucky," we could probably still show you interesting and relevant content. And that's where I spent the bulk of my time at Google. How do you detect whether a piece of content is personally relevant, and how do you detect whether a piece of content is generally interesting? Since then, I've moved on to WeBeData. I'm one of the founders and I act as our CTO today. We've been around for about 3.5 years. It's a pretty small startup based in San Francisco. We're 40 folks today. And what we've spent our time on in the last few years is helping customers move from collecting and storing and analyzing this data and taking it into action. This is very relevant for large retailers, large financial institutions who have a lot of information about their customers, and they want to say, how can I take everything there is to know about Bob or Sally or Jane and use that as input to a decision that can be made in real time a prediction about what that user might do or what that customer might purchase, prediction about what's most probable to convert for product recommendations or whether this transaction is risky or fraudulent, and provide that decision through an API that can be consumed in a number of different touch points. It might be your ATM machine if you're a bank, your point of sale system if you're a retailer, the website, the mobile app, to provide a unified experience where really everything that you do with that customer, the entire experience is informed by everything there is to know about an individual. And in that journey, I've spoken with a lot of different companies about where they are in the evolution of Hadoop and big data adoption. And I want to share some of those experiences with you and some of the kind of themes of use cases. So first, I'll tell you a little story about the early adopters of Hadoop, how I've seen things play out. And this is mostly analogous to actually how things worked internally at Google, and we're seeing it play out in open source again. At Google, we had this big problem. We had all these machines with data on them about what users were doing. These were all logs. And then we needed to store it so that we could keep it forever. We needed a place where not only we could keep it, but we needed to organize it, and then we needed to understand it. We needed a processing layer, so we had MapReduce, to be able to begin to ask questions. And now you're seeing the same thing play out in industry, that we're building layers on top of raw MapReduce. We're building things like Hive and actually using those to write SQL queries that get boiled down into MapReduce jobs. We see Scalding, Scrunch, Scooby, a lot of these higher level languages. We're seeing new processing paradigms. We're seeing Pregel and some graph processing. We're seeing Spark. And I think that story played out at Google is playing out again. But it's happening in this wave, and different companies adopt at different rates. Don't pay too much attention to the logos I put in here in particular. I'm just trying to show an example of what I mean. That the people who were very early to adopt, and even I would call innovators in the sense that they were actually driving some of the open source projects in Hadoop that people are consuming today at the front of the wave. And then it takes a little time. There's some people that say, well, I'm not at the forefront of this technology, but it's interesting to me. I want to keep tabs on it. And when it makes sense for my organization, when I feel like I can prove value in the short term, it's time to adopt. So let me just characterize, rather than using logos, I don't want to get caught up in the particular companies. I'm just going to draw a little cartoon here. I was joking with somebody the other day about all the water-based metaphors. I have another Hadoop water-based metaphor in this ocean here. But we have our early adopters as these little nimble fish. They move quickly. They're able to test out technologies. And then maybe the early majority or late majority that move a little bit slower because they want to mitigate risk. Can I get a sense really quickly, just a show of hands, of who, not as an individual, but whether you feel like your company is in the early adopter, party versus the early majority? Raise your hand if you are the early adopter type company. Okay, not too many. That's good, because really my target audience is the early majority. Okay, great. All right, that's who I want to speak to. That's fantastic. So focusing on the early adopter, here's what I've seen play out. They're swimming along, little nibble fish, just minding their own business, and one day it sees this Hadoop thing. What's this technology here? And other things are popping up. We've got Hive, we've got HBase, and it can be a little bit overwhelming, but because they're interested in trying new things, this conglomerate of all these technologies that are popping up, some may last and some may not, these early adopters have been able to glue together into some coherent system to solve a particular problem. And these particular problems might not have a huge amount of business value on day one, but these early adopters have been willing to take the risk that, hey, if I do some cool stuff with technology, we can extract that value later. So the use cases from early adopters are typically not tied directly to business revenue. They might be, well, I want to just glue this together, organize some stuff, and now I can collect everything. And then I can go sell that to my business and say, hey, how much value could you get if we could really collect everything there is to know about our customers, for example. And because early adopters are quick to move, I've noticed that it's been pretty easy for them to go and change things around a little bit, re-architect, swap some components out for others, and then let this system not only do the original use case that it was intended to design for, but now do something else. Now in addition to be able to collect everything, now I can keep everything forever. And then with a little bit more work and maybe plugging in another few more components, they say, now I can ask anything. And this is kind of where I see a lot of the marketing today, asking anything about all of the data that's available. And this is, I think, I would map it onto traditional BI, but done in Hadoop over all the data that you have in your organization. So the point I want to make today, and what I'll spend the bulk of my time on, is that if you are one of these early majority or late majority even that are on the outside looking into these early adopters, you see these little fish swimming around. They're doing cool things. They're working on stuff like these little technology-based use cases. If you see one or two, you might not think that's worth your adoption or your attention yet. If you see a few more, you start to think, well, maybe I should too. But in that process, I think that there's three blind spots that I want to cover that I think are difficult to see. One, the use cases from some of the early adopters that might be very exciting don't make it above your threshold radar. And I want to talk today about what those the very next step, next generation use cases are that some of the early adopters are working on, because there's value there that you might be excited to use. The second is those little architectural bubbles. What's going inside of there that needed to change? What new technologies needed to get adopted? What became obsolete to move them from the original use case to this add-on use case? And then finally, from the outside, you can see all of these early adopters working on use case 1 and then use case 2, getting better understanding of their data. But what was the ultimate goal? It's hard to see where these early adopters are ultimately going. And if you kind of follow them blindly, you might go down a path that might not ultimately make sense for your business. So summarizing those blind spots, one, I want to talk about what are some new high-value use cases that early adopters are working on. Two, what are the architectural changes, the patterns that are working well or maybe not so well for these early adopters that you should be considering as the early majority? And then finally, where do we think they're going? What's the ultimate end goal here? Because if you can focus and design for that, maybe you can get there a little bit faster. So the meat of my talk here, I'll just go through 1, 2, 3 of these blind spots. The first one is next generation use cases. What are people working on today? And I'll breeze through these slides because I think these ones are pretty obvious to you. You hear a lot about this at the conference today. If you walk around the vendor area out there, or we're at the panel this morning, hearing some of these large companies like Kohl's and Target talk about the use cases they're working on. Recommendations is obvious. You see that in terms of content and products. You're also seeing recommendations expand to things that are not just content and products. You're seeing that for social companies recommending people. And the thing that you're recommending, the algorithms might be the same, but the content might be completely different. Recommending transactions or actions that you should take as an investor, or in the case of Civ Science, recommending users that you should take a deeper look at to detect fraud or other risky activity. Search. Now that you have all of this data collected in one place and sitting in Hadoop, it might be enterprise data that's internal to your organization, and you want to be able to surface that and ask questions of it. Tools like Splunk and Cloudera Search internally are great for doing that. Externally, you want to be able to do search for your customers if you're the type of company that provides a search piece of functionality. I see a lot of personalized search. Prediction and prevention. Predicting whether something is going to happen before it actually happens, and then more importantly, doing something about it. In the case of Climate Corp, trying to figure out what's going on with weather to help agriculture. In the case of O-Power, one of our customers, trying to figure out, can we tell people about how they're using their energy, where they're not being so efficient about it, where they're different from their neighbors, and recommend action to take. Or cell phone manufacturers and carriers, can we predict when someone is going to want to upgrade to a new phone, or maybe have trouble with their existing one because they're playing Angry Birds too much, and say, hey, do something about it, as opposed to waiting until they do the customer service call. Targeted offers. I'm seeing this a lot in finance right now, as they start to focus on customer experience. But one of the larger themes, I think, is really customer experience. Bringing all of this data that was just understanding within an organization and bringing it to the front office. Can we affect the customer experience for all of our users in real time, depending on what context we have, how they're interacting with them, and what their personal tastes and preferences is. And we should be able to use every point, click, and swipe there is to be able to inform that. Their experience on tablet or mobile should be very different from on store. They're not equivalent. We should be consistently providing a good experience. So clearly, I hope I've made the case that early adopters have moved beyond ETL, despite the fact that I think most people who are adopting Hadoop at the very beginning and I don't think there's anything wrong with this. There's a real business need that you need to justify your budgets to go invest in a bunch of machines to go build a system. that replaces some old technology, that you need to show value in a very short amount of time. And if that just means doing some ETL or some data warehousing, that's great. But I think that the huge amount of value is coming next. And I'll divide these next generation use cases that I just kind of went over into two categories. One is, now that you've got all this data ETL'd in one place, we can go deeper within understanding. I can ask more questions. I can do more segmentation. I can get 360-degree views of my customer, do visualization, figure out what my ROI is really in a data-driven way, and maybe predict what's going to happen. But the second is action, and this is where I get really excited. It's not just about asking questions, but what's the point of information if it's just nice to know? I really want to turn it into something that I can do for my business. And this is where I see the use cases on the other side that mostly I went over here. Recommendations, mobile offers, preventing something from happening that you don't want to have happen, doing real-time search and search personalization. So on a diagram, what I've seen, to just kind of illuminate this branch here, I've seen that people generally, not people, organizations, as they go through this evolution of data sophistication, go through these phases. At first, some people say, well, I know that data is intuitively valuable. I should be collecting more of it. I should know more about my customers, at least keep track of what they're doing, even if I don't know how to use it right now. Let's just keep it all. And that's what Hadoop has enabled us to do. It's enabled us to collect all this information blindly with trust that we'll be able to extract value from it later. Then they get to organizing it. Now, there's no point in collecting all this data unless we can get it into a form that I can begin to ask questions. And then finally, can I ask questions of it? Can I get answers in an ad hoc fashion? This is where we're getting a lot of plugins from Hadoop into tools like Tableau and MicroStrategy and whatnot. So this is where I think the industry is today, but where I think the early adopters have moved on. They've already proven value in the understanding category, and they've either gone deeper into the understanding, or they've moved on to the action. And I want to encourage the people in the room today that there's a lot of value in doing that and tell you how to do that. So blind spot number 2 is changing architecture. What are people doing differently within those little architecture bubbles, gluing together all of these pieces of open source into a platform that they can extract value from? The point I want to make here at a high level is that sometimes supporting a new use case, moving from phase 1 of collection to organization or organization to understanding to action, requires a fundamentally different architecture. Sometimes it's easy. You just need to plug in a few pieces of technology here and there. And sometimes it's very different. And I think that we're on the cusp of something happening very different between the understanding and the action phase. And I don't want people to get trapped in phase 3 because there's a lot of value in phase 4. So what that looks like as people move along, especially if you just follow these early adopters going through, they said, I want to collect more data. Let me instrument my systems so that I can spit out more logs. As they go deep into collection, they might build collection frameworks and put the pipes in place using tools like Flume or Kafka or Storm to get data streamed and have the ingestion kind of taken care of across the enterprise. And then they move on to organization and say, well, I need to get this ETL'd into a form that I can ask questions of it beyond just sitting in a bunch of log files. And to go deeper, I need to maybe use tools like Hive and HCatalog and think about data governance so that it's accessible across the enterprise. Moving into understanding, providing the BI tools to let people ask questions of this, plugging into their existing systems. And I think what's changing now is this last act phase is pretty hard. The architectural changes required to go from incrementally adding features to the system to enable the change from collection to organization to understanding has been relatively minor. And now there's a pretty big shift, and I think a leap in architecture that people are making to get to the action. If you're not careful, it's pretty hard, and I don't want you to fail. So what are the key ingredients for this last phase of action? Well, certainly we need the data. We need to go through the first phases of collection, organization, and understanding. We need to get it all in one place. Sitting across the enterprise in different silos is not going to help you do anything. You need to organize it so that you can ask questions, and those are kind of required to understand. The next things, to do action really well, it's not that you're going to plug your recommendation system into this Hadoop framework that you've built and suddenly extract the most value possible. You might have some recommendations. They might be reasonably good. But I'd argue that Netflix and Google and Amazon have shown that rapid experimentation and iteration is really the key to success here. So I think that there's some key ingredients in taking this data into action is that you really need an experiment framework. You really need to be able to try something out as soon as possible and let your machines optimize. And you're human beings as well. If I have a hypothesis, I need to do that. So as a human being that works at one of these companies, if I'm a data scientist or an engineer and I have an idea about how to provide better product recommendations, how to better detect risk or fraud from a credit card transaction, or whether someone's going to buy a mortgage, or what disease somebody might have in a healthcare situation as an insurance provider, I want to be able to test that hypothesis as fast as possible, tune it, make changes, and see the results of those experiments as fast as possible. And then real time, and by real time I mean here that everything there is to know about a particular entity that you want to analyze, in most cases a user or a customer, is available to these models, these experiments, and these actions that you're about to take. So I think in the example of retail, I think we've all shopped around on something, a website, I won't point any fingers at anyone, but where you buy a book or a piece of clothing, and after you check out, for the next 10 minutes or even a day or a week, you're still getting recommended that thing that you already purchased. And I think that people are growing up now in an environment where they're used to their organizations really understanding them, and that's going to become unacceptable. So architecturally, what happens here? In the collection phase, what I've seen people do generally, you have your users out here, they're interacting with your business. If you're a web-based company and you have a web presence, people are going to their browser, they're hitting your web servers out there. And I'm using web as an example here, but I think generally the idea of consumers interacting with your business through touch points is beyond just web. And the first step is, well, I would need to collect information about all that. I need to get all the logs into one place. And HDFS and other distributed storage systems have been the place to do that. I just get all my logs into one spot. And as I go deeper into collection, they say, well, there's other sources of information that are relevant. I have third-party systems that might have demographic data. I have transaction systems, product information management catalogs and things. And I might have point-of-sale systems or other touch points. And we need to get all that in one place. So as they think about how do I organize this so that it's accessible across the organization, I've seen people start to ETL all this in. And this is kind of where people were maybe last year. And some companies still to today are kind of on this step. But as they go deeper into organization, they're providing a platform layer even for the collection so that any system can plug in very easily with an API and say, hey, if you are a data provider, if you have information about the customers, I want to feed it in through this simple pipe and eventually know that it'll eventually end up in my data warehouse or data lake or data ocean, whatever you want to call it. And then getting towards trying to start understanding this after it's been organized. And maybe you need to do some more ETL to really get it to the point that you can ask questions of it. We've seen MapReduce. And I'm using particular names of technologies here, but you should generalize this. I'm seeing MapReduce, Spark, Storm, all sorts of processing engines to get data from its raw form into something cleaner so that this can ultimately be turned into a real data warehouse. And then when we get deep in understanding, well, I have all these processing tools now, and I want to use my smart people that understand my business to ask questions and get answers so I can build reports and charts to hand to the executive team to say, this is how you should spend your marketing budget next year or your advertising on Google AdWords, given what we know about our customers. And we've been able to use MapReduce to show that. And whether it's MapReduce or something on top of it like Hive or Pig or some stuff in the libraries built in open source, I think the result is all the same. They get some insights. They show those insights back to the business, and they start to get a little bit of value. Where things get really complicated, and I think you've seen now, moving through these phases, there have been relatively minor changes that I've made to the architecture of this at a high level. I haven't really needed to do much to get from collection to organization to understanding. And now getting to the action gets a little bit harder. So what I see people do is, well, I already have this system in place. What's the minimum I can do to start plugging this data back into something that I can present to my customer experience? For example, if we're talking about product recommendations, they say, well, I already have this data warehouse now that has all the data that I need to give product recommendations. I have MapReduce and other tools that my data analysts or data scientists can use to go build those algorithms. And I've spit out some data that says, here's a data file that has all the products that I should show for a particular customer. And the next logical step is I just need to put that in some sort of serving system. HBase, Cassandra, some other key value store so that each customer can have all the data that's relevant to them that needs to be served. And then I can provide APIs so that my website and other touch points can consume that served data. So this is what I see people do over and over again. And this is the natural thing to do. But when I go back to this slide about what I think the key ingredients are for doing action really well, that experimentation and rapid iteration, it's not really there. We've got the data, it's consolidated, it's organized. You don't really have experimentation, rapid iteration, or real time. The cycle time of going through the data warehouse is preventing you from really keeping up-to-the-date information about your customers. You're not able to really experiment and optimize because the data scientists are working on these new hypotheses, generating a data file, and then handing them over to engineers to ultimately try to deploy to production. And that sometimes takes weeks or months, and we really want to make this take minutes or hours. So as people realize this, and the early adopters, I've noticed that they say, well, I've added the serving capability, I got this key value store going, I might get some indexing on there, but now I want to get real time. So I've added a stream processing layer in front of this. I put Storm in front so that I can ingest data in real time as people are clicking around on my website so that those can drive inputs to my recommendations algorithms. And Storm and Samza are examples of those. And I've also seen a lot of buzz about the Lambda architecture later. And this is really adding both. Can I join a speed layer, a serving layer, and a batch processing layer to get all the benefits of real-time action based on this data? So what does that look like? And I hope to show you here that it works, but it's significantly different from an architecture from what you have today. So we got to move HBase to the side a little bit, or the key value serving system. This is still kind of the batch layer that's going to go through the process of data coming in from the very top, flowing through these web servers, getting to the data warehouse. Your data scientists or data engineers doing some processing, spitting out the results, and going here into the serving system. But this is slow. This happens on a day's life cycle at best. So how do we get stuff in real time? Well, in the Lambda architecture, we can add a kind of a speed layer that's going to take all the information about stuff that's happening out here in real time as these points and clicks and swipes are happening. Let's pull that streaming data into a processing system like Storm or Kafka or Samza. And then what I need to do next is join these two things so that when somebody comes to the website or my mobile app and says, what's the next best action for Bob, or what's the recommendations I should show him, that API should go through some sort of query layer that joins the kind of batch slow data with the real-time information that's coming together. And this absolutely works, and in the Lambda architecture, this is a high-level diagram, but this essentially over here is the batch layer. This is the serving layer of that batch data, and the speed layer here, and there's some joining that happens. You can already see that there's a lot of stuff to add to this diagram to get you from the understanding to the action. But even if you do that, I argue that there's still a struggle for organizations that are using this architecture to have great usability and rapid iteration when it comes to experimentation. You've definitely got the real time now, but you don't really have this. Why? Because as a data scientist now, if I come up with a new hypothesis for how to create a better recommendation algorithm than I was before, what do I have to do? Well, I need to do some ad hoc querying to validate that hypothesis. But once I do, I need to encode that in the batch layer. I need to do some work, do some changes here. And then I need to go change that in the Storm or the stream processing layer. And then I may or may not have to also do some work in joining that data together. And again, this is all possible, but I really want to move us to a world where the optimization and iteration of this goes very quickly. So what we've seen in a few places, and this is actually the architecture that we use at WeBeData in our open source Kiji project, is a little bit different. And we're optimizing for this experiment and rapid iteration. Is we're still going to use HBase as our real-time component. But rather than just using it as a serving layer, we're also going to use it as, you can essentially think of it as a view of real-time data. So as people are clicking around on the website, making every point click and swipe, or purchasing things in the store, if you can ingest that in real time, let's use that to update a 360-degree view of each customer. Each row represents one customer, and that'll be up to date. And that can be served directly to systems that need to consume that. In this particular example, that recommendations algorithm. So I'll use HBase for that view, and as a data scientist, I can still read data about individual customers, that 360-degree view, directly from HBase, using the same tools that I would before. I can read other data from my data warehouse if that's relevant, that piece knowing that it's not necessarily in real time. And then instead of generating a data file, which is the result of my analysis, and then handing that over to a serving system, I'm going to put that into another system that's responsible for executing that in real time as users are interacting. So as customers are coming to the website and clicking around, this scoring service can provide an API endpoint that on the system's behalf is reading the models that have been deployed by these data scientists from some sort of model repository, reading the data from HBase, and then saying, hey, everything there is to know about this 360 view for this customer. Load that into memory, execute the algorithm for an individual user, provide the best action for that user given all the context up to this moment, and send it back to the caller. But notice that this architecture is fundamentally different than what it looked like before in a few slides when I was talking about understanding. So architecting for action now, as I hope to demonstrate in a good way where you have great experimentation and iteration, is pretty different from architecting from understanding. And as a business now, I want to make the case that if you care about that last phase of getting to action and you want to do that well, perhaps you should be thinking about the problem backwards, starting with the requirements and working your way back, as opposed to trying to slowly evolve from understanding into action. So the argument there really at the base of this is that you can't really build a data platform for a problem you haven't identified yet. And what I've seen over and over again is customers saying, well, LinkedIn and Facebook are building things in this way. I'm gonna do that too. But they're not seeing behind the scenes all the work that they're doing that might not be relevant as an early majority or late majority large enterprise. So I want to challenge enterprises to say, what are the requirements first of, do I care about real time? Do I care about experimentation? Do I care about rapid iteration? And if I do, if you are going to build a platform for that, you better be designing a platform from the beginning. And if you're not, if you're going to go through this evolutionary period, this is not your problem. Your core competency might not be in technology. There are plenty of vendors out there in the exhibition hall that can help you get those point solutions until you figure out exactly what your requirements are. Because you don't know what's next. I don't know what's the next phase after action. It could be something else, or maybe it's not even an evolution, and maybe this is a circle. I really don't know. But what I do know is that the value is greater at the end part of this evolution. I think that, don't ignore the axis on the left, the 100% thing. I'm just trying to prove a point here that as you move along this phase, and I think this is intuitive, that you're getting more and more value out of your big data infrastructure as you move from collection to organization to understanding to action. But the point I'm making with this kind of increase from understanding to action is I think that most of the value is in that action. Unless you're taking the information that you have, asking questions, and then doing something with those answers. And you're not extracting all of the value. And this is for two reasons. One is I think that more and more decisions are being made by computers and not human beings. It's not the case that I'm going to build out a report and then ask an executive to go do something about it. It's not the case when I go to google.com and I search for something, there's a human being that's going to show me what's best. It's going to a machine, and an algorithm is handling that. And as that happens, we need to build the systems and architectures to enable the data to flow to those systems in real time. And the second is, as we get more and more data, humans are going to be a less relevant component of that. The last point I want to make here is around where people are focusing their time, even when they are working on this action piece, when they're getting data flowing through this in real time. Here's what I think of, and this is the scientific method here in a circle slide. I as someone in the business or a data scientist have a hypothesis. I ask a question. I get a hypothesis for what I think is going to happen. I predict what's going to happen. I test it, and then I validate that by doing some analysis. So where do people spend their time today in doing this on top of a Hadoop architecture today? One is they spend a little bit of time asking questions, but if you want to accelerate that, what would you do? You'd hire smarter people. If you wanted to accelerate the hypothesis generation phase, you need to do a lot of ad hoc querying. You would want to build data warehouses, essentially, that people could ask questions and get answers faster. And I think it's appropriate that people are working on making this cycle time faster, and faster data warehousing is really what this comes down to. If you want to do better at prediction, again, we would hire smarter people. If you wanted to do better testing, we need faster deployment. We need to go quickly from my hypothesis to a test that I can run in production and see live experiment results from. And then finally, if I'm going to do analysis on that, again, I need to get answers to the questions quickly. But in this loop today, where do you think that people are spending most of their time? It's not equal across all of this, and it's certainly not in the hypothesis and analysis phase. It's all in that testing phase. It's in the deployment. And so if you look at how people are actually spending their time, it's all soaked up in this testing phase. And really, we need to work on, as a community, as an industry, on accelerating the deployment so that we can run experiments, not necessarily working on the faster data warehouse piece. So what does this all mean? The conclusion here is that the real value is in these next generation action use cases. It's not going deeper, it's not building faster data warehouses. The architecture for action is pretty different. And so as an organization that may not be an early adopter where technology may not be core to your business, I want you to think about how you might approach that problem by thinking backwards. Start with the requirements and go backwards as opposed to trying to evolve your existing architecture for understanding and adapting it to the action use case. And related to that, design for your problem since you don't know where the end goal is here. Requirements first, then technology. So my ask here is stop focusing on building faster data warehouses, and this is all my opinion, by the way. You can take this advice with a grain of salt. Focus on taking that data into action. Focus on running experiments, focus on optimization. I get the sense that most people in this room, certainly at the talks that I'm going to, they already understand their data. They understand their customers. They've got the governance. They've got the data warehousing in place. Let's do something with it. I'll leave that slide up there, but we have about 4 more minutes for questions. We have a microphone in the back. Feel free to
If you have
raise
any
your hand.
questions, if you could please just raise your hand and I'll bring the mic to you.
So on your architecture diagram, the blue space, if you were going to throw a technology in there, what would you put there?
Can I ask what you work on first, because I don't say something that's in conflict to what you work on?
I'm a developer.
Okay. In that blue space, the technologies, that's the ingestion piece. So I think a couple of years ago, I saw Flume being the kind of leader there. I see a lot of Storm and Kafka. So today I would say Flume, Kafka is the first place that people look, and then Storm, especially now with Samza, especially with Samza increasing the Kafka part. Like I don't know which one I see the most, but those are the technologies I would list out.
Do you know of any architectures for getting things back to the web space that you like?
Things getting back to the web. So I talked about the Lambda architecture a little bit. I talked about the architecture we use for Kiji. I think just like anything else, there's trade-offs amongst those. Those are the only two that I see a lot of, besides the more primitive, hey, let's just put it into a serving system and not deal with real time. I'm seeing people that are doing just one component or the other of that, maybe trying out Storm or Data Torrent or some of these other technologies that do stream processing, and they don't even do the batch piece. And if you don't need that for your use case, I think that's okay. I'm obviously biased. I like the architecture that we've developed at WeBData for Kiji, and that's most reflective of what we had built in my experience at Google.
Thanks.
Did that answer your question? You have another question up here? Okay.
I'll be to you in just a second.
Hi. In one of the architect graph, you showed that all the data aggregated back, and then you have the HBase database. Yeah, this one. And then if you click more, there's a scoring system. Mm-hmm. And then after that, the scoring system going back to the web instead of your HBase. Can you elaborate? What does that mean?
So if you work backwards here, I'm a web service out there, and let's talk about maybe a recommendations use case first. I have a zone of the website, and a user is logged in. I know some stuff about them, and I want to say, what is the list of products that I should show here in this zone of the site? So I make an API call and say, here, this user ID has logged in. Here's the page that I'm on. show me the recommendation. So that's going to the scoring system. And the scoring system now, given the user ID, needs to look up everything that is relevant as input to the model that generates the recommendations, essentially scoring the recommendation model. So those are maybe the last recent transactions, demographic info, and so on. And that's what it's reading from HBase. And then the result of that score, which is essentially the recommendations, just get fed directly back to the website. It could, in addition to doing that, store that information back in HBase again in that user's row, in essence, building up new derived information about the user. And that's actually what we do with Kiji as well, and you can think of that now as a real-time view that's being updated not just with inherent or transactional information or event data, but also derived insights or probabilities.
Okay, so in this case, you're talking about a website that you actually have total control over.
You have the instrumentation to change something on the website, yes. Are you in a situation where you don't have control?
No, I'm just wondering, if you have a certain designs in place that any website adopts this standard of plugin so that your feedback to any of the website could influence how that website reacts.
Absolutely. So you hopefully see that there's a feedback loop here. If you follow the arrows around, as people are interacting, that's flowing into the real-time view in HBase. And then the scoring system is reading the results from that back up to the website. So there should be a feedback loop so that every interaction and touch point is affecting the next best result.
Right, but right now, there's no such standard or plugin that allows all the browsers to take that feedback from you, right?
Not that I'm aware of.
Okay, thank you.
One last question.
I should mention that the transport protocol and the standards that we're using for the scoring APIs are just RESTful HTTP APIs. Yeah.
Hi, my name is Bharat Kono. In one of the initial slides you presented, you mentioned that collect everything.
Mm-hmm.
How important or how critical is to collect everything? It may apply to some companies, but not all organizations.
Yeah.
So my question is that, is it important to collect everything, or is it is required to collect everything, or is it more important to collect what you need and process the data? That helps you with the data storage, data processing, and the ability to sort through the little smaller set of data to identify what you need.
That's a good question. I think it depends on whether your company is an early adopter and willing to take the risks to go collect everything even before you know how you're going to use it. That's the approach that hopefully tools like Hadoop, by lowering the cost of storage for all of this data, is going to allow you to do without much business justification. Because you want to be in a situation where, as later when you're sitting on all of this data and you have a better hypothesis, like, man, I really wish I had all the transaction data, or I really wish I had information about where people are from or their Facebook or Twitter data, that you can just act upon that then, as opposed to say, now I got to go instrument a new collection thing that might take another 3 to 6 months of development. So hopefully the answer is that if you're on Hadoop already, that the justification of storing everything, or at least a large subset of everything, is low enough cost that you might as well. And the schema on read capability is going to let you just put it all in there and deal with the ETLing and processing of that later. But the reality is that the types of companies that we work with at WeBeData are still in the phase of trying to prove out value. You're still trying to justify the business that this Hadoop thing is even worth it, or the technologies on top of it are going to be worth it. And for that reason, we typically see people start with a known subset of data that is going to be useful, prove out value, go through the whole end-to-end cycle, and then you can go back and say, okay, now that we've proven value, we should just go collect everything.
Thank you.
I think that was the last question we had time for. Thank you very much.
Thank you.
Have a good lunch.